Welcome to the Vertical Aerospace Analyst presentation. We'll be getting underway shortly, but ahead of that, some housekeeping. Please see here the usual legal disclaimers, which should be read in full. Today's presentation will be broken into 5 sections. There'll be the opportunity to ask questions at the end of each of the main sections, and listeners will also be able to ask any wrap-up questions at the end of the presentation. If you wish to ask a question, please post this in the box on your screen. Your first speaker will be Stephen Fitzpatrick.
Thank you all for joining us today. My name is Stephen Fitzpatrick, and I'm the founder and CEO of Vertical Aerospace. We are here to show you why we believe Vertical is the only eVTOL company that has both the engineering capability and the right business model to be successful in this sector. I will introduce my colleagues in a moment, but before I do that, I know a lot of you folks probably won't be familiar with my story. So let me take just a couple of minutes to let you know how I got here, what inspired me to launch Vertical, and why I'm so high conviction on the opportunity in electric aviation and eVTOL in particular. Before launching Vertical, I successfully built a multi-billion-dollar revenue business called Ovo Energy. After years of studying how decarbonization of the power sector and digitization of the consumer experience would completely disrupt an entire industry, I launched Ovo Energy in 2009 and have grown it into a $6 billion revenue business with 5 million customers in a heavily regulated industry. I funded it with my own capital and bootstrapped the first 5 years, building a lean and highly productive organization. I'm no longer involved in the day-to-day running of that business, but I remain a majority shareholder of the company. I know it is required to build a winning organization and significant value for shareholders, manage risk, manage costs, and work within a heavily regulated environment. I'm not a serial entrepreneur, but I was so high conviction on the opportunity at Vertical that I brought in a professional management team to run Ovo so I could concentrate my time on making Vertical a huge success. Investing more than a decade in understanding how to help consumers reduce their carbon footprint led me to a significant realization. The technology exists today to decarbonize almost every part of our lives apart from flying. After spending much time understanding the constraints in aerospace, I came to the realization that eVTOL was going to be an amazing opportunity to bring electric technology to aviation, to create vehicles that would not only decarbonize how we fly, but completely transform how we think about travel. To date, I personally funded most of the capital in the company. I think about the business who somebody has skin in the game and have designed the business model to take advantage of the enormous opportunity, but also to do so in a disciplined, executable way. To summarize, we've built our business based on existing technology, to work within existing regulations, and to use existing infrastructure. The individuals presented today are part of a much larger and exceptional team who have joined Vertical over the last 5 years. We have truly world-class engineers at our base in Bristol, led by our president, Michael Trevenka, who has been with the business since 2019. Prior to that, he spent 20 years at Rolls-Royce, where he was head of future technologies, and today he will talk through our key technology decisions and how these differentiate our business. Paul Harper heads up certification and has been with Vertical for the past 4 years. Prior to this, he was with Airbus for more than a decade, where he was the UK's chief airworthiness engineer for the A380. He will describe why we're so confident on our path to certification. Eduardo Puerta, our chief commercial officer, was formerly the CEO of Airbus's urban air mobility business and will provide an update on our customer engagement and the significant progress we've made on building our forward order book. Finally, Vinny Casey, our CFO. He's worked alongside me for nearly a decade. He was the CFO at Ovo, playing a key role in helping grow the business from a standing start to where it is today. He will talk you through Vertical's unique business model and financial metrics. Urbanization is the biggest trend of the 20th century. As populations continue to grow, especially in emerging markets, this trend shows no signs of slowing down. The technology that help us build the world's greatest cities, electricity, steel, concrete, and the automobile, continues to support the growth of urbanization, but it is coming at a terrible cost. Our cities everywhere are grinding to a halt. The average traffic speed in Midtown Manhattan reached an all-time low in 2018 of just 4.7 miles per hour, and it is not nearly the world's most congested city. It's also damaging our health. Air pollution is now a greater cause of death globally than smoking. But we have simply reached the point where creating additional transport infrastructure, whether connecting urban neighborhoods or local city pairs, is becoming impossible. There is simply not enough room left to build more bridges, more tunnels, more freeways or railways. Where new infrastructure is possible, it's becoming prohibitively expensive. In the UK, the flagship rail project, HS2, connects London and Manchester, a distance of just 220 miles. It has already reached a projected cost of $150 billion, 250% over budget, and is still years from completion. We need a new solution. This is not what the answer looks like. Some futuristic technology or approach that still needs to be proven, yet alone certified. The reality is, you can't take a new battery that exists somewhere in a lab and put it straight into an aircraft. We think the answer looks like this. A vehicle that's capable of flying 4 passengers, 100 times quieter than a helicopter, 100 times safer, 100 miles, and all with zero carbon. We are using existing technologies that are commercially available today. We have assembled the world's leading aerospace engineering team and working with some of the world's best companies that have certified aircraft and their components many, many times before. That is what takes this from being a moonshot project to an engineering reality, and is what I believe is the biggest differentiator between us and our peers in the eVTOL sector. I founded Vertical before anybody had heard of eVTOLs. But over the last 12 months, it's clear that a huge amount of excitement is being generated, and more people are becoming aware of the opportunity ahead of us. So what has changed? The fact is, we've reached an inflection point in the energy density of lithium-ion batteries, with the energy density increasing over 50% in the past 7 years, while costs have fallen by 80% over the same period. 270 watt-hours per kilogram translates into a useful mission distance of more than 100 miles. The falling price of batteries means that the vehicle operating cost is now just above $1 per seat mile. And these are numbers that are based on technology that is commercially available today, not something that still needs to be proven or industrialized for production. This means this amazing technology will soon be available and affordable to urban citizens all over the world. Why do we believe we will be successful? As you can see here, there are 4 clear and compelling reasons. The overarching theme is our unwavering focus on the quality of our engineering and how this informs our entire approach. First, we are really confident in our ability to certify this aircraft. The number one challenge in our industry is simple. It's not selling the vision. It's not improving that the business model works. I think we all know that flying over traffic is an easy sell. It's not even in demonstrating that technology works, but it's in building an aircraft safe enough to meet the world's most stringent safety standards and earning the trust and confidence of industry partners, regulators, and of course, passengers. Safety is priority 1, 2, and 3, and there are simply no shortcuts. In this industry, experience really counts, and it's why we've focused on building the world's most qualified aerospace team with an unparalleled track record in delivering certified aircraft and propulsion systems. Alongside this, we're partnering with a roster of amazing world-class engineering partners. Second, we have an unrivaled order book and global distribution capability. We have agreed already the sale of 1,350 aircraft, covering key markets such as the US, UK, Europe, Japan, and Brazil. These contracts are of course conditional on us certifying the aircraft, but they represent a powerful validation of our vehicle design, certification approach, technical capabilities, and the size of the global market opportunity. No other eVTOL company has this volume or geographic reach. Third, our asset-light approach results in capital requirements less than half of our peers. Our approach means working within the existing aerospace ecosystem, respecting established engineering processes, and leveraging mature and proven supply chains. Partnering with the likes of Honeywell, Rolls-Royce, and GKN not only de-risks our path to certification, but it also allows us to leverage their incredible design and manufacturing capabilities. And lastly, we are realistic on the current market backdrop. We have valued the business sensibly and even modestly based on our strong expected earnings and cash flow and the significant momentum we have in our business. Before passing you over to Michael, I'm delighted, proud and humbled to be able to share with you messages from some of our key partners who wanted to tell you firsthand why they're so excited about working with Vertical.
Emerging technologies are critical to the race to reduce carbon emissions, and we are excited to partner with Vertical Aerospace to develop the next generation of electric aircraft. American has agreed to pre-order up to 250 aircraft. This represents a potential pre-order commitment of $1 billion.
Avalon is a global leader in the aircraft leasing sector. We have 837 committed aircraft flying with over 150 airlines all over the world. We've always been identified as a thought leader, and that aspiration has led us to partner with Vertical. We believe this aircraft will be the first to be certified, primarily because of its partnership with Rolls-Royce and Honeywell. Their understanding of the roadmap to certification is the key differentiator. But indeed, perhaps most importantly, in the conversations that I am having with airlines all over the world, and we expect to announce over the coming weeks a number of orders for our aircraft, I fully expect demand for this aircraft to far exceed supply.
Honeywell's very excited about Vertical's aircraft. The Vertical team has a tremendous history of innovation and design excellence. We believe that coupled with what Honeywell brings to the partnership, is a recipe for success.
So Virgin Atlantic has a tremendous history of innovation challenging the status quo. The partnership with Vertical allows us to really innovate by bringing in planes which are electric, zero emissions, and with our operational excellence, we can really innovate in a place where we had not done so before.
Microsoft's mission is to empower every person in every organization on the planet to achieve more. And we are executing this in our partnership with Vertical Aerospace. Vertical is redefining flight as it advances sustainable aviation through its zero-emissions electric aircraft. Microsoft is proud to partner with Vertical to pioneer the electrification of flight.
GKN Aerospace is the world's leading multi-technology Tier 1 aerospace supplier, and we're delighted to be a part of Vertical's quest for more sustainable air travel.
Solvay has more than 40 years of experience in the development of materials for aerospace. We are delighted to be able to help Vertical deliver their vision.
At Rolls-Royce, aviation has been part of our heritage for over 100 years. Vertical Aerospace products might be new, forward-looking products, but they're built on decades of Rolls-Royce experience at certifying products and ensuring their safety in the air. We're looking forward very much to bringing two of the best innovators in UK aviation technology together.
My name is Michael Trevenka, and as Stephen said earlier, I was previously Head of Future Technologies at Rolls-Royce. I have 25 years of civil and military aerospace experience, and I know what it takes to get the best engineering talent and to get these aircraft certified and flying. I have no doubt we will be successful. There are a number of reasons for this confidence, much of which Stephen has already touched on, but today I will focus on providing more detail on our technology and the key decisions we have made that we believe give us both a competitive advantage and significantly increase our ability to successfully deliver on our plan. Firstly, we have been doing this for the last 6 years and have already successfully flown 2 prototype aircraft multiple times. You can see here on the left the VAX-1 and on the right the VAX-2, which we flew in 2018 and 2019 respectively. These are not models or mock-ups, but full-size proof-of-concept aircraft that our engineering teams have designed and built from scratch and tested under regulatory conditions. The VAX-2 demonstrated superb aircraft handling qualities during a deliberate motor out, which is a critical step in EASA certification, and many of the lessons learnt from these previous 2 designs are being translated over to the VAX-4, which is currently being built. We have actually built multiple subscale drones before these proof of concept aircraft, so we have been continually learning and refining what our final product might look like. The drones and full-scale demonstrated delivered a huge amount of learning for us on areas such as flight control systems, battery and electric powertrain integration, not to mention developing the processes and capabilities to successfully deliver a safe flight test program under regulatory approvals. We have gained a great deal of experience and insight from this long-term program, and this, I believe, puts us in a very strong position relative to our peers. Fundamentally, there are a number of different ways of configuring eVTOL aircraft in order to take advantage of electric distribution systems. We took the view a long time ago that the product we would take to market needed to be a winged vehicle. However, to aid our learning, our early aircraft testing for the VAX-1 and VAX-2 were multicopters. These are really useful technology demonstrators. However, they are relatively simple vehicles and are far less capable of being commercially successful in most markets. They were part of a useful research activity for us as we looked to develop the VAX-4, which is the aircraft you see on the right. The move to vectored thrust is not an easy one, and I'm happy to give more detail later on this in the Q&A, but one of the reasons we are confident on this move to vectored thrust is the technology and certification experience Honeywell is bringing to us on flight controls. Any organization trying to do this alone will face some real barriers without Honeywell's decades of expertise. So whilst we are seeing a coalescence around vectored thrust in the sector, the choices we have made in how we go about this are very much different to our peers. Here you can see the design of our VAX-4. We very deliberately based this vehicle around currently available technology and a view informed by our certification experience that regulators will not switch to embracing things that are unproven. From a tech perspective, we have designed this aircraft with safety and economics in mind in order to capture a mass market opportunity. We have deliberately designed a piloted aircraft as we are convinced that this will be mandated by the regulators and expected by the public in most parts of the world for well into the next decade. This drives the need to carry up to 4 passengers for the economics of the aircraft and the sorts of flights that we will be making. It will have 0 operating emissions, be near silent in flight, and capable of traveling 100+ miles at speeds of up to 200 miles per hour. Critically, the inherent efficiency of the aircraft also makes it ideally suited for high-value short emissions, such as the typical 15 to 25-mile airport city centre routes expected to enable rapid battery charging and aircraft turnaround in 10 minutes or less. As Stephen has already touched on, we believe the calibre of the team we have been able to attract to Vertical is second to none. We knew from the outset that certification would be the greatest initial challenge, and that is why we have deliberately recruited people who have experience designing and certifying aircraft. In total, they have cleared 30+ aircraft and propulsion systems, and collectively, we have more than 400 years of experience in Formula One, automotive and technology sections, adding technology expertise, performance and agility to our team. As you can see from this slide, these are senior people who have done this work at the most senior level in their previous organizations. I will call out a few. Our head of engineering, Eric Sampson, was engineering VP and chief engineer at General Dynamics, certifying the structures of all the latest Gulfstream jets, and an EASA-approved head of design organization. Tim Williams spent the last decade as chief engineer for Rolls-Royce, and Paul Harper was UK chief airworthiness engineer at Airbus. Our head of battery, Dr. Limhai Somerville, led much of the battery systems development at Jaguar's electric vehicle program, and he leads the eVTOL Euro CAE battery certification group that is defining all the battery standards for electric aviation for EASA. These individuals exemplify the level of experience in our business and a strong track record of delivery that we are fortunate to have across the company. The experience of this team has enabled us to make a number of strategic technology choices that define our business model. These choices enable us to focus on areas that are strategically important to our business, while partnering with world-class experts where technology already exists. This also has the added advantage of significantly reducing our CapEx and maximizing our certification confidence. Let me explain. At the top of the slide, you can see that both batteries and rotor technology remain our in-house expertise. We made this choice because the novel nature of eVTOLs means there were no existing partner solutions available for these key components. They're also both areas where the IP is both strategically important and fundamental to the economics of the vehicle. Put short, we don't believe anyone can do it better than us. Where world-class partners are already successfully building the key components that we require, we have chosen to partner with them. This is not only because they have a proven track record of building and certifying these components, but also because they have each invested years and billions of dollars to develop this technology. Why try to add complexity and cost to our business model if it's not necessary? Rolls-Royce has a world-leading electric propulsion unit, and their aeronautical pedigree is second to none. They already have 1,500 flight hours of electrically powered aircraft under their belt and are developing a bespoke, lightweight, compact system for the VAX4. GKN has the manufacturing technologies to produce the wing that we require, and Honeywell has industry-leading safety-critical flight control hardware and software expertise from, among other things, the F-35 Joint Strike Fighter. It's hard to overstate just how complex the flight control systems for these novel vehicles are, nor the huge certification challenge involved, and I'm grateful that we're able to bring to bear Honeywell's many decades of broader experience in this field. Solvay brings significant proven capabilities in lightweight composites across aerospace, motorsport, and high-end automotive, which are critical in meeting the certification requirements and enabling the mass manufacture of the vehicle. Vinny will provide more specific detail later on how these decisions dramatically reduce our CapEx requirements. This slide brings the example to life for you. The VAX4 is designed around existing technology and best-in-class components developed by our industry specialists. You can see the number of years each partner has invested in developing these technologies. This is work we have not had to do or spend on. I will break down into more detail the technology and systems we are focusing on in-house, and I will go through each of these in more detail over the next 4 slides. There is a perception that the battery cell technology we are using is unproven technology. The truth is the battery cells are already in commercial automotive applications. This is critical as the regulators require proven, repeatable, high-quality mass cell manufacture, as well as enabling us to source cells at competitive prices. What we are doing, however, is bringing all of the automotive capabilities and technologies and focusing on how to apply these to an aerospace application. This know-how that we've been building since the company was founded in 2016 is a very big differentiating factor for Vertical and is key to our success. The 2 key factors we are focused on are the fact that aerospace regulations are different from a safety perspective. This is why we have done a huge amount of safety testing under the EASA standards, which are much more demanding than the FAA standards. It is why we have already carried out crash and thermal runaway testing under EASA and CAA supervision and completed extensive safety testing on these bespoke batteries. The second key factor is optimizing the battery system weight and performance. The battery is the single largest contributor to aircraft weight, and we are targeting a class-leading battery pack energy density of 200 watt-hours per kilogram using commercially available high-energy dense lithium-ion battery cells at 270 watts per kilogram. We are leveraging Solvay's lightweight fireproof composite materials in a battery system that has been highly optimized around the specific requirements of our aircraft. In addition, we have been developing state-of-the-art charging and battery health diagnostic capabilities in conjunction with Warwick Manufacturing Group, a world-leading battery research establishment here in the UK. This enables us to safely utilize the maximum available energy from the battery and optimize when we swap them out, minimizing operating costs. Our advanced rotor technology minimizes noise but maximizes safety to cope with, for example, bird strikes. As with everything we do at Vertical, we arrived at our unique design with an approach centered on engineering expertise. We have the former top expert on composite fan blades from Rolls-Royce. We have top university partners researching aerodynamics and noise, and we're running state-of-the-art simulations, large and small-scale tests from which we learn and constantly iterate our designs. Optimizing aerodynamics is critical. We start with state-of-the-art aerodynamic simulations, ranging from individual parts of the aircraft all the way up to modeling the entire vehicle. These can be hugely computationally intensive calculations, and we're fortunate to have Microsoft as a strategic partner and investor supporting us with the very latest in cloud-based high-performance computing technologies. We then validate these simulations. An example of this is the precision-made VAX4 scale model shown undergoing testing at the Airbus wind tunnel facility up the road from our Bristol site. One of the key features of the VAX4 design, and what we have planned from the outset, is the recognition that we will see continuing advances in technology and a wide range of applications for these aircraft. We have therefore designed it to be modular, upgradable, and scalable. This includes the ability to incorporate new technologies as they become available, for example, by retrofitting improved batteries or increasingly automated flight control and avionics systems. The aim here is to ensure it is readily upgradable for other missions that we know there is demand for. So all in all, we have proven expertise, the best team, a design that can address the largest market, and a strategic approach on what tech we develop internally and how best to leverage world-class external partners. With that, I will now open to Q&A on this section.
My name is Paul Harper, and I am the head of certification. I've been with the company since 2017, and before that I was with Airbus for 12 years, working in roles including UK Chief Airworthiness Engineer for the A380 and Head of Engineering for the A321neo wing. Vertical recognised very early on that certification would be crucial to the success of the company, hence why a Head of Certification was recruited in the company's first round of expansion in 2017. And in that time we've been steadily and consistently building our capabilities, developing our learning and how we collect our evidence, and building our working relationship with the authorities. As Michael mentioned, our learning has evolved and moved us to the VAX4 architecture. And that learning and certification de-risking continues through, and we have our next prototype aircraft in production and are implementing further capabilities to allow us to test, learn and gather certification quality evidence more quickly. As you can see from the images on screen, we have major structural components coming out of mould with our suppliers. Some images of the powertrain and wind tunnel testing, and an illustration of the bespoke simulation facility that is being built in our facility as we speak. This simulation facility has been designed to meet the applicable requirements and guidance to allow it to produce certification quality data. We now have a clear roadmap to certification. Our approach to certification has meant that we have deliberately designed the aircraft around meeting the most stringent global safety standards being set by EASA and the CAA. The certification basis is set out in the EASA SC VTOL, which gives a really clear, transparent and level playing field for certification applicants. We have absolute clarity on what the authority expects of our certification basis. Both we and EASA recognised early on the mass market potential for eVTOLs, and that with the numbers of vehicles expected in service, operating in exacting urban environments, new levels of achieved safety would be needed to be defined and realised to protect the passengers and public. This has resulted in the enhanced category of VTOL vehicles that certification will be required against to operate in an urban environment. This requires the same level of system safety as that used for a large transport category aircraft, as well as enhancements over what is required for helicopters. We have all rightly come to expect and trust being safe on or overflown by large commercial airliners, and this is what the VAX4 will deliver by following the EASA requirements. To put this into numbers, these safety levels equate to system failure rates leading to a crash of no more than 1 in 1 billion per flying hour. This is 100 times safer than that required for an equivalently sized aircraft. To achieve these enhanced certification standards is a significant undertaking, and as Michael outlined, we have very deliberately selected best-in-industry aerospace partners, experienced in certification and qualification, to partner with and support us in critical areas. We chose these partners because we believe they will significantly de-risk our certification program by bringing years of specialised certification experience and capacity. We will work with the validating authorities, as we will with the certifying authority, to ensure that the regional needs are met, and I will touch more on this in a moment. This is planned for, and the certification team is structured to provide dedicated support to all the validating authorities. We have already passed several important milestones laying the foundations to our certification. We've been in communication with our airworthiness authorities and are working along a clearly understood path to certification. This is more than just about showing a safe design. It is about showing we have a competent company, both in our ability to design and in our ability to produce aircraft. Our CAA DOA and accreditation and recognition that we are a company able to meet the strict requirements needed to design an aircraft is in process and on track. We have been allocated our DOA number on a provisional basis, and their team is ramping up to finalise the audits of the governance manual and assurance system we have submitted. The DOA enables Vertical to hold a type certificate and, by extension, allow our customers to obtain certificates of airworthiness for their aircraft. It is core to the company ability to generate revenue, and we are progressing well with this, and we look forward to sharing and celebrating the passing of this milestone in the near future. Our VAX4 prototype will operate unpiloted, and we expect piloted flights in 2022. To this end, we are working with the CAA and have a clear route to obtaining the necessary flight permissions for each test phase. Full EASA and CAA certification is currently expected to be achieved at the end of 2024. Our aircraft will be CAA certified and concurrently undergo a foreign validation of the type certificate with EASA. We have aligned our certification basis with EASA requirements, so we know that we will meet the EASA expectations. In order to accelerate the development of industry consensus standards that support the requirements and regulatory means of compliance that they have established, EASA has teamed with EuroCAE, with the involvement of other airworthiness authorities, standard bodies and industry, to set up a working group on VTOLs. I'm pleased to say that when we look at the 5 key working groups that are establishing eVTOL industry consensus standards, Vertical and our partners are playing key roles in each, and in the case of electrical, chairing that group. Our working in partnership with EASA and other authorities in this forum cannot be underestimated. Vertical is helping to write the requirements for eVTOL vehicles, and in so doing is able to ensure that our designs meet the critical safety standards set by our regulator. As already noted, EASA intends to reinforce the certification requirements for VTOLs to ensure new levels of safety are achieved in the very demanding operational environment of mass-scale urban air mobility. This initiative is something that Vertical fully endorses, as ensuring public safety and continued confidence in the mode of transport is essential to allow the sector's mass-scale growth to proceed as expected. This does mean that the EASA SC VTOL goes above and beyond in some areas from what is currently called for in either the CS or FAR 23 or 27, the standards that would be called upon if certification basis were developed as allowed for by the FAA. And yes, it adds additional challenge to the design. The advantage of taking the EASA approach for our design requirements, and this is really critical, is that there is a very high probability that these requirements, and by extension our design and justification documentation, will map across directly to the validating authority. This is not necessarily the case the other way round. In short, if you want an EASA validation to sell aircraft into Europe, you will need to address any shortfalls between your certification basis and SC VTOL, including the accepted means of compliance. In some cases, such as rotor cascade or critical parts, this could result in extensive or impossible redesign for those coming at it from a different perspective to ourselves. So in summary, we and our key partners have been working along our path to certification with our airworthiness authorities for some time, and we have accumulated experience from our prototypes and a clear understanding of the design requirements. We know what is expected and are continually working towards this so we can significantly de-risk our validation exercises and move closer to certification. With that, I will now hand over to questions.
Ladies and gentlemen, my name is Eduardo Domínguez Puerta. I'm the Chief Commercial Officer at Vertical Aerospace. I joined in May. Prior to that, I was the CEO of Airbus Urban Air Mobility. I've spent 6 years on the eVTOL space, where I had the opportunity to lead the technology development, vehicle, infrastructure, regulation, and aerospace. And maybe more important to this discussion, I led the setup of a ride-sharing business, VOOM, that operated during 3 years in Brazil, in Mexico, in San Francisco, and we even demoed in Shenzhen. During these 6 years, I've learned a lot of things. The first thing that I've learned is that it's very difficult for big corporates to disrupt themselves. They might want, but they will need to continuously fight their DNA and conflicting priorities and allocation of resources. They are also not well known for speed of execution. The second thing that I learned is that these products are difficult to develop, to certify, and to industrialize. You shouldn't do it on your own. It would take a lot of cash and a lot of risk. It's better to do it with big partners, reliable partners, people that have the experience and can help you through. At the same time, you also need to have the best engineers, not only the new ones that know about electrification and new generation vehicles, but also you need to complement with experience on certification. That is really important. The third thing I learned is that going to market is nearly as difficult as developing the planes themselves. You need to create a brand, you need to create a B2C platform, you need to learn how to operate the planes, deal with regulators, infrastructure providers. It's a titanic task, too much risk. We have actually decided that we shouldn't be doing that on our own. We should create in the right ecosystems with world-class partners that can help us in this endeavor. All these lessons learned brought me to Vertical. I believe we have a great team, capable to take on the challenge. I believe we have a great product, as it has been validated by the market, and I believe we have the right strategy to make this a reality. All that being said, let me now share with you what I believe is the strongest order book in the eVTOL market. Since June, when we announced our conditional pre-orders from American Airlines, Avalon, and Virgin, we have been able to add additional customers. This is important because we have increased the reach and the typology of those, adding Marubeni in Japan, adding Bristow, and Iberjet from Group Avaris. This is important because this has helped us diversify our customer base and access to different target markets. Some of our customers are airlines, some of our customers are helicopter operators, lessors, or hotel groups, which shows the huge usability of our products. That dialogue with our customers and that clear OEM positioning plus services has enabled those discussions with them. And being close to your customer is very important. It informs how your plane needs to be developed, and it informs the type of missions that they will undertake. In that sense, we're starting to see 3 primary uses. The first one relates to big hubs and airports in the world. There are about 50 to 100 megacities in the world with huge airports and traffic of passengers. Airliners can see our products as a way to extend their services, offering their passengers a transit from those hubs into their final destinations. We believe that that is going to be the first type of missions that will flourish, and we believe that there's going to be a lot of demand for our products there. The second type of mission that we're talking about with them is a point-to-point type of mission between cities around 15 to 100 miles. Actually, in the world, there are around 66,000 city pairs within those distances. And if you imagine trying to filter those into the ones that have a real passenger flow, could help us identify different uses on that regional type of aviation. The third one is around island hopping, is around tourism, is around connecting and offering different experiences to people that today cannot be done with helicopters. Those type of missions are helping us define something beyond our VX4. Actually, we're not just developing a plane, we're developing a family of planes. We want to have a single base for certification, but through variants, through different versions, and through options, we would like to customize it and tailor to the application of our customers. In that sense, we will explore the creation of medical versions, we will explore the creation of cargo versions, and of course, we will need to adapt our planes to be able to fly in high heat environments, over islands, fulfilling with floatability and ditching requirements, or even in colder or at a higher altitude type of missions. Now, let me discuss a bit more in detail about those customers, what do they bring, and more importantly, how are we planning together to use our planes. Let me please start with American Airlines. American Airlines have agreed to a conditional pre-order of 350 planes. They have around 200 million passengers per year, serving more than 350 destinations, 10 hubs in the US. Who could be a better partner there? Let me show you and illustrate how we could use those planes and how we could create business opportunities with them. Let me show you the New York case. In New York, you have Newark, JFK, and LaGuardia, 3 major airports. Getting into Manhattan is challenging. Once you're there, if you want to go to Hamptons, it gets also challenging. Today, this market is served with helicopters, actually limiting the amount of frequencies and limiting the accessibility of passengers due to the price points they require. We believe that by introducing a fleet of around 50 planes, we could generate a business of 100 million revenue per year and transport more than 500,000 passengers per year, creating value for them and saving them time. This New York example could easily be replicated in the different hubs, like Chicago, Dallas, Los Angeles, Florida, and actually extend throughout the US. Let's have a look now at Virgin, our UK partner. Virgin has agreed a conditional pre-order of 150 planes and is working with us to try to bring these operations in Heathrow. Heathrow will be the start. We're defining 9 spokes around it, and we're defining which could be the network routes that should be served. We're mobilizing NATS, the airspace service provider in the UK. We're mobilizing the airports. We are supported by UK Innovation and Research, and we would like to bring those commercial services in 2025. Initially around London, with a real intention to extend them at different regions in the UK. Let me now talk about Avalon, one of the largest lessors in the world. Avalon actually is more than a customer. It's a real way to get to the airlines. They are managing today more than 800 planes with an operation of around 31 billion. This relationship has proven to be successful already, with the placement of a leasing contract between Avalon and Gol, one of the biggest airlines in Brazil, with up to 250 planes. Let's talk Japan and Marubeni now. Marubeni has agreed a conditional pre-order of up to 200 planes and will partner with us to try to introduce our products in Japan. Japan has traditionally been a highly technological country with a particular orography that makes mobility a challenge. We believe that Osaka 2025 will be a great opportunity for us together to showcase advanced air mobility. We have talked about airliners, we have talked about lessors. Let me now talk about helicopter operators. Bristow, one of the biggest and most respected helicopter operators in the world, has agreed to a conditional pre-order of 50 planes. This is great news for us, but I believe this is the beginning. They are the first helicopter operator to make the step change towards sustainability. Others will follow. Bristow is a very strong partner to us, not just as a customer. They also provide the capability to operate vehicles in 50 countries around the world and will help us generate additional partnerships to complement capabilities in different regions. Last but not least, Iberjet from Group Avoris has committed to a conditional pre-order of up to 100 planes. They want to bring advanced air mobility to the Balearic Islands. They want to bring advanced air mobility to the Canary Islands. We want to explore the catchment area of Madrid and Barcelona, like we're doing with Heathrow and New York. And additionally, they want to bring these vehicles to all their Caribbean operation. Iberostar from Avoris Group belongs to a conglomerate that manages more than 250 hotels around the world and has or is using today a fleet of around 2,000 vans to transit tourists between airports and final destinations. Additionally, they will be able to provide experiences, excursions, sightseeing, new services that our vehicles will be able to provide. In summary, 1. The strong order book has validated our product and our business model. 2. The global demand confirms that our approach on certification is the right one. 3. Our partner ecosystem gives confidence on our successful to-market strategy. Thank you very much. I'll be happy to take your questions.
My name is Vinny Casey, and I'm the CFO of Vertical Aerospace. As you've heard from Michael, we have a superior aircraft. Paul has shown you why we are confident on our path to certification, and Eduardo has talked through our route to market and the real momentum in our conditional pre-order book. I will talk through how these are all driving our asset-light approach and putting us on a path to an expected 1.4 billion of adjusted EBITDA in 2026. We have a 3-phase development program over the next 4 years. On the following pages, I will talk through how our funding requirements and commercialization strategy bring down our net funding costs to a level that we believe none of our competitors can match. The 3 phases are non-sequential and can be flexed as required. However, let me step through each one from left to right. Phase 1 is our design and certification program itself. Funding will support the continual build-out of our world-class engineering team, further development of our proprietary battery and rotor technology, and the ongoing milestones of our certification program. From 2023 onwards, Phase 2 will enable us to scale production to meet growing demand for our aircraft. We plan to build an assembly facility with an expected annual capacity of 1,500 aircraft and expandable to 3,000 aircraft. In Phase 3, we will build out our commercial platform further, including delivering our aftermarket services and R&D to drive range and passenger variants. What this means is that after Phase 1, we will have a certified aircraft. Phase 2, a full-scale assembly facility, and Phase 3, a fully commercially built-out platform. Here I'm going to set out a more granular detail on the funding for each phase. The key point here, looking at the net funding requirement on the right-hand side, is that we expect to require less than 250 million to certify the VAX4, develop a manufacturing facility to meet and exceed our conditional pre-order book, and further build out the organization. This is based on what we believe to be conservative assumptions, which I will now talk through. Through to the end of 2022, the capital plan is focused on Phase 1, the certification program. From 2023, our funding requirement increases across all 3 phases as we invest in our state-of-the-art assembly facility. This expenditure is partially offset by pre-delivery payments from our customers. These deposits have been based on the assumption that during the 18-month period prior to certification, we will attract down payments to secure production capacity on a consistent basis as large airframers today. We expect to announce more orders in the near term, and as a result, these would increase accordingly. The net effect is that our gross funding requirement of around $500 million is reduced by half through a mix of existing cash, pre-delivery payments, and gross profit contribution. What this bridge illustrates is firstly that our partner ecosystem model is expected to lower capital expenditure, and secondly, our focus on selling aircraft to established players is expected to begin generating real near-term earnings and cash flow at the earliest opportunity. This provides the platform for further growth from 2024 onwards. The chart on the left shows a breakdown of the unit costs of the aircraft. Our partnership approach also gives us real visibility and certainty on costs, relying on Tier 1 aerospace suppliers. As CFO, I feel great that Honeywell, who have been certifying avionics systems for decades, are providing our software, compared to developing the code internally ourselves with the inevitable cost and overrun uncertainties, particularly in a post-737 MAX environment. On the right, the chart shows the splits of costs between operating expenses and COGS. We expect our operating expenses to fall significantly as a percentage of revenue from 2024 onwards as production volumes are scaled. We believe this visibility, combined with the conditional pre-order book, provides significant operating leverage to maximize profitability. Here you can see on a slide, and aggregating all of the building blocks in this presentation, of why we're confident of exceeding $1 billion adjusted EBITDA in 2026. On the top left, you can see that our already agreed conditional pre-order book equates to the majority of our available production through to 2027. This means that our revenue targets on the chart below are projected to be already covered over this period. Moving to free cash flow on the bottom right, we only need to sell just under 100 aircraft a year to be cash flow break-even, and our total investment is recovered through the sale of around 300 aircraft in aggregate. This is over 4 times covered on consummation of the existing pre-order book and means we would be cash flow positive from 2025 onwards. Top right EBITDA illustrates the significant operational leverage in the business with confidence of $1.4 billion adjusted EBITDA by 2026. This slide sets out where all of our work over the last few years puts us relative to our peers. We have successfully flown full-scale prototypes, which has developed our capabilities and provided invaluable learnings incorporated into the design of the VAX4. We have the largest conditional pre-order book, providing momentum to the business, insights and learnings from our partners, and good visibility on expected revenue. Our partner ecosystem optimizes our capital plan, resulting in a significantly lower gross funding requirement, and their experience providing certainty on costs. Bringing this all together, we believe we are valued modestly based on our expected strong earnings and cash flows. That brings me to the end of this final section, and I welcome any questions from me or the team as a whole.